A 100 kg sign is hung from the end of a horizontal support beam that is hinged to a wall. This is a beam, is hinged to this wall at this vertical wall at this point, and a 100 kg sign is hung here at this other end of the beam. The beam and the signs are supported by a cable. This is a cable, so the beam is supported by a cable at this point. It's been attached, and okay, the beam and the signs are supported by a cable that is attached to the beam and above to the wall, which is here. The beam is 2.5 meters long. That is the length of the beam, which is this L is 2.5 meters, and the cable is 3 meters. The cable is 3 meters, which is C. From here to here is 3 meters. The beam and the cable weigh a small amount when compared to the sign. The beam and the cable weigh a small amount when compared to the sign. Find the attached position of the cable to the beam that minimize the tension in the cable. So the position of the cable on the beam is this X. So find the position of the attachment position of the cable to the beam that minimize the tension in the cable. So to minimize tension in this cable, there is a position of X. There is a value of X that will give you minimum value. So at the point where you have a minimum value for the tension is where, now let me give you, now if you solve for that, you have equation. Let me just write the equation for the tension with respect to X. Equation of the tension with respect to X will give you T equal to mass G L C X. Let me use X square root of then in brackets C square minus X square so this is a tension. This is a formula for tension. This is the equation for tension and the cable. Now where you have minimum tension is the differential, that is differentiation of the tension with respect to X. These are the points where you have, at the point where the differentiation of the tension with respect to X is equal to 0, is at the point where you have the minimum tension. So, and the value of X at that point where the differentiation of the tension with respect to X is 0 is the position, is the attachment position where the tension is at a minimum value. So now if you differentiate this with respect to X, we'll now have an equation that looks like this. Equation that looks like this. This is dt the T over the X equal to this M times G L C your brackets 2x square minus C square over X square square root comma C C square minus X square raised to power 3. So this is a differentiation. This is differentiation of the tension with respect to X. So at the point where this is equal to 0, it is at the point where you have minimum tension, and the attachment position, which is the X at that point, is a position where the cable should be attached to have a minimum tension. Now let's now solve using Excel spreadsheet. This is my input position. Let me now make an input. Format this to be use black. Then the text should be white so that it will be visible. Here would be mass over sine of sine is the length of beam acceleration due to gravity length of cable. Now let me use this. This is 100 from the question. The length of the beam is 2.5. The length of the cable is 3. Acceleration due to gravity is 9.8. So the units are, this is a kilogram per gram, this is meter, this is in meter too. This is in meter per second square. Second square. Per second square. Now let me change this. Let me change the color of this one to blue. Now let me make this M. Let me rename this M, this cell M. Rename this. This is the length of the beam L. This cable, what you see, let me rename it C. If I put C, it will not work. Look at it, it will not work. Now let me use C. Let me see. C underscore enter. Then this, let me use G. So I'm using this so that it will be in line with what is already written here. This, so now then this area, let me say this is the calculated value. Let me copy this to this place. We call this calculated. This is a calculate. Okay, we can call it calculation. Calculation. Now here is X. Okay, let me call it attached position. Attached position of the cable. Okay. Let me make it capital letter. Attached position of a cable. Use a small letter. Cable. The attached position of the cable. Let me expand this. Here, let me choose. Let me just say this is X. Now this is called this tension in the cable. Okay, let me see. We're looking for the minimum tension in the cable. Then here we'll call this the differential. Okay, let me just represent it to weight. We represent it with this mathematical sign. This mathematical sign. So this is the tension. The tension T. This one is X. So here is x, here should be okay, then there's no need to okay, let me put it there is t. Here is the t underscore sorry the x because this plus is not underscore the x, enter. So given this value, now let me select the whole of this select the whole of this, select this all border, this one all border, then let me go to view tab, remove all grid lines. So I have something like this. Now here is a meter, here is Newton, here is Newton per meter. Then let me assume here to be 1 meter. So what we're going to do is we assume here to be 1 meter, then we input the formula here, we input the formula of the tension, the minimum tension here, of this tension here. Then we use GOSEC. We use GOSEC to look for a value of x, as in a changing value of x, where this will be 0. The value of x will be changing to a point where the Excel will help us to do the alteration, whereby this value will be changing by using GOSEC. So let me input this formula here. Let me say this is equal to m times g times l times c divided by x divided by square root of c raised to c square minus x square so this is what you get for 1 meter. Now the differentiation of the tension with respect to x, that is what we're going to do now. It's equal to m times g times l times c times two times square minus C square divided by x square divided by C square minus x square raised to power 1.5. So you have this. Now, to get the point, the attachment position of the cable on the beam where you have minimum tension is at the point where this value is equal to 0. So we now use go seek. You go to data. We use this what if analysis. Go seek at the point where this is equal to 0. Why this is changing? Because this. Then so this is a minimum tension. This is a minimum tension, and at this attachment position 2.12, that is the answer. Now let me reduce this. Let me make this a whole number. And then this, let me change it from scientific mode to number mode. Let me increase the decimal place. See, this is roughly 0. Now I would like to write a program whereby if you make any change here, the thing will automatically calculate itself. Look, let's look for example. Now if I make a change here and here, let's say 3, and here let's say 5. No, it shows that this, and let me change here to, let's say 1. See, this does not give me a minimum value of this. Does not give me minimum value of this because there is no program that will tell you, okay, that go seek. It will tell you, okay, there is a go seek here for you to do it, for you to be able to get the minimum tension at this point. So for us to do that, for us to write a program, I'll teach you how to do that. For us to write a program so that when there is a change in any of this value, the thing will give you the exact answer as with respect to what value you have put input here, to give you the minimum tension as with respect to what you have input here. So for us to do that, we'll go to developer. Go into this developer. If you don't have this developer on your spreadsheet, you go to file, option, look at this customized ribbon. At the customized ribbon, you check this box. If you check this box and say okay, it will appear here. So now what we'll do, we'll go to Let me change this to what are we doing? Let me say tension calculation. Let me rename this to tension. To tension. Let's say cable tension. Let me name it cable tension. Cable tension. Now you go to Visual Basic here. This is cable tension. This is a cable tension. Look at this. At this general, you choose the worksheet. Now at the worksheet, you choose the change. Let's change. Now we're not making use of this one. We're not making use of this. So here is where we're going to write the is where we're going to write our code that will enable us to do the GOSEC without going through the data what if analysis and GOSEC. With this code, any change in the value there, it will just calculate your minimum tension, just as we did it the other time. Let me give you, like, there is no need for you to say, okay, let me go to tension, let me go to data first. We should be at this point where we want to be at this point where we want the value to be 0. We say data what if analysis GOSEC, put here 0, make here, then choose here that you want the value to be varying. So in order to get at a point where this value will be 0, you just say click. This is it will be at 2.82 with respect to what was given, with respect to this value is given, because I've changed the value. So this will not give you the exact answer to that question. So let's now write a program so that if you put the exact value, you get that 2.12 that will go there that time. So what I will now do, I will say dim. Let me say dim uche. Let me say dim onwa sanya as boolean. Boolean meaning true or false. It has two character, two distinct, to true or false. Then now what I will now do is I will now say if this random if rand let's say range the underscore dx the round off of this, let's say 5 decimal number of digits after decimal as long, so you say 5 is not equal to 0. If this which is this. So I'm referring to this cell, the cell of the differentiation of tension with respect to x. So this one is giving you the number of decimal place, and if it's not equal to, if it's not equal to 0, then I will now say and not on one sign. I'm using my name, my surname, and not on one sign. Not on one sign. I say then on one sign equal to true. Then if it's not this, then on one sign equal to true, you now give a condition that will make this go sick, because if this is not equal to 0, then when it is not on one sign, then when it is on one sign, it will now go sick to make this 0. To be able to now use go sick function to be able to calculate your minimum tension. So now let me put in this thing. So what I will now do is, if this is this, I will now say range this range of the differential this differential dot go sick the goal will not be equal to 0, comma, changing cell equal to range of x. So now on one sign equal to false, you say end if statement. Now I will now have to save this. Saving this, let me call this cable tension calculation. Okay, let me say minimum cable. Make it minimum minimum cable tension calculation. Minimum cable tension calculation. Now, since I've written a code, if you save it with Excel workbook, it will not work. But if you save it with Excel macro enables worksheet, it will work. So I'm saving it with this. I haven't saved it with that. What I will now do is I have this to be this to be this to be this. So if I change this to, let's say, 100, change this to, if the length was 2.5, this thing was 3, You see, you're having this to be 0. This is the minimum tension in the cable, which will go to the other time, and this is 2.1 to the attached position of the cable. So now if I make any changes here, let's say I change this to 120. Now it has given me the minimum tension 1960 at the same point. Why is it at the same point? Because the length of the beam has not changed. The length of the cable has not changed. If you change the length of the cable, the position will change. Let me say this: the length of the cable is 4. See, the position has changed and the minimum tension has changed. Then this one will still remain at 0. Now let me also change. If I change the length of the beam, it will also change. Let's say make the length of the beam 5. You see, there is a change here. Okay, let me bring it back to that 2.5. You see, okay, the change was a minimum change, but for the position, the attachment position, if let's say 6, so it's still almost the same thing, but the tension is varying. If you say 5, the tension varies. Let's say this is 5, it reduces. If it's 6, the tension and the cable will increase, almost the same position. Now it means that the length of the cable, if the length of the cable remains constant, okay, let me say the length of the cable, let me use 3. If you use 3 and you're changing the length of the beam, the position, the attachment position will not change. Now let's say this is 6, but the minimum tension will begin to increase. If you increase the length of beam, the minimum tension will increase. If you reduce the length of, let's say, let me make the length of beam to be 2 instead of 2.5. You see, it has reduced. If you make it 2.5, it will increase. For 120. Now, you know, our initial this thing was 100. It's 16.33 at the same point. Now if the length of cable remains the same, if the length of cable is the same, if the length of cable is 3, which is constant, and you're varying the length of beam, what will happen is that the attachment position of the cable will remain the same, but the minimum tension in the cable will change. Now let me use 3. See, the minimum tension has increased because I moved from 2.5 to 3. Now let me move. If I move from 3 to 2 less than this thing, to reduce, it will be less than the value for 2.5. This is 2. The value for 2.5 is 1633. See, 2.5, 1633. You see, but the position will remain the same. Even if you make it 5 here, the position will remain the same. Make it 6 here, the position will remain the same. So with this, you can be able to make some good engineering judgment to your work. So with help of Excel, you can do a lot of manipulations in your work. It will help you to make a good engineering it will help you to take a good engineering decision in your work.